Okay, so I'm afraid the computer calculator is not working, so I'll just have to go through the work, like the workings of this, and then you can actually put stuff in your calc. Right, okay, so so find the length of the arc. First thing we need to do is look at the formula booklet. Okay, so length of an arc is L equals theta times R, and theta, remember, has to be in radians. R value is in radians, so A is going to be 1.3 multiplied by the radius, which is 3, which is 3.9. To find the area of the shaded region, so we're using this formula now, but we're looking at the shaded region, which is this bit. Now, you've got two choices here. Either you find the area of this green bit and then subtract it from the whole area. So, okay, that's one method. Or you can find this angle and then use the formula down below for this sector. I'll do both just so you can see the difference. So if we were going to find the area of the green sector, that would be half multiplied by 1.3 multiplied by 3 squared. So that's 9 over 2 multiplied by 1.3, which is, I don't know, it doesn't really matter. Okay, but that's the green part. And then we would have to subtract that from the area of the whole circle. We know the area of the circle is pi r squared. So that's pi multiplied by 3 squared. So it's 9 pi. And so our answer would be 9 pi subtract 4.5 multiplied by 1.3, whatever that is. Alternatively, you can do the blue method, so find this angle, and we know that a full circle would be 2 pi. Oh, why isn't this blue? 2 pi, and then we're going to subtract 1.3, and this is going to give us this angle here. So we would have a half multiplied by 2 pi minus 1.3 multiplied by 3 squared. This gives you 9 over 2 multiplied by 2 pi 1.3. Anyway, you get the same answer. Okay, there you go. Oh, which is 22.4. Just FYI. Okay. fx, find f dash x. Alright, so let's look at the formula booklet to help us. So we're going to differentiation, calculus. Actually, we just copy all of this. Oh, I don't think the bottom bit's confused, but it doesn't matter. Okay, so ln x. So we look at ln x, that gives us 1 over x. So I know some of you were getting confused and you were starting to rewrite stuff. You only have to rewrite stuff if you've got fractions. So for example, if it had been 3 over x squared or something of that nature, where the x is on the bottom of a fraction. But for ln, you don't have to rewrite it. You can just go straight forward and differentiate it. So the derivative of the first term is 1 over x. So a f dash x is 1 over x. And the derivative of minus 5x is just minus 5. So that's our first derivative, 1 over x minus 5. B Now our second derivative, we have to differentiate this. Now this is not a useful fallback because we've got x on the bottom, as we just said. So we're going to rewrite this as x to the minus 1 minus 5. Excuse me. Now we've got it as a power, so now we can differentiate. So the second derivative excuse me, power comes in front, take 1 off the power. This term doesn't have any x's attached to it, so that would just disappear. So this would just be equals negative 1 over x squared. You can leave it as this if you wish. Now we have to solve when these two equal each other. So part C is 1 over x minus 5 equals negative 1 over x squared. Alright, solving equations. We can bring our x's to the same side. So I'm going to add 1 over x squared to both sides. And I'm also going to add 5 to both sides at the same time. So I've got 1 over x plus 1 over x squared is equal to 5. I need to make this a single fraction, so I need to make my denominator the same. So I'm going to multiply top and bottom by x. So I've now got x over x squared plus 1 over x squared equals 5. Joining numerators now, so we've got x plus 1. Okay, now I can multiply both sides by x squared. So that's going to be x plus 1 equals 5x squared. And now I can see I've got a quadratic. So I'm going to move everything to the same side and have it equal 0. It's the calculated paper, so you can solve it on the calculator. And you need to actually looking at the answers. So if you can't remember how to do that, I need to show you in person. Essentially, you're going to polysmalt, and you're finding the roots of a polynomial. Of course, you can use the quadratic formula. So a is 5, b is negative 1, c is negative 1. Oops. So x would be positive 1 plus or minus the square root of negative 1 squared minus 4 times 5 plus minus 1 over 2 times 5. 1 plus or minus the square root of, so that's 1. And 4 multiplied by 5 multiplied by negative 1 is negative 20, so that's plus 20 over 10. So that's 1 plus or minus root 21 over 10. So there's your two solutions. You could probably leave it like that if you weren't confident using the calculator at all. Alright, find the term in x6 of the expansion. X plus 2 to the 9. Okay, so again, let's look at the formula booklet. And this, remember, is what you're looking for. Or perhaps I should copy that bit as well. And that's for okay, so when it's a plus b to the power n, this is our general term. So for us, we've got a is x and b is 2. So so a is x, b is 2, n is 9. Oh, so we need to establish the value of r. So we're going to use this and have 9r. x to the power of 9 minus r, 2 to the power of r. Okay, so now we want to find the term that's got an x to the power 6. So this part here has to be x to the power 6. Now the only way of getting 6 here is if r was 3. So now we can fill in everything. So it's 9, 3, x to the 9 minus 3, 2 to the power 3. So we can use our calc to find 9, 3. Oh my god, I'm so snotty. I don't know what 9, 3 is. Anyway, if you have 9, 3 and multiply that by this, which is 8, apparently you get 6, 7, 2. Okay, so that's the answer. Obviously the 9 minus 3 gives us 6. Alright, now hence means that you're going to use this information. So we know that our term with the x to the 6 in is 6, 7, 2, x to the 6. If we want to find the term x to the power 7 in this expansion, it means that firstly we need to find the... Oh no. So if we were to expand this, we would have each of our terms of our expansion here multiplied by 5x. So that means that the only term that's going to have an x to the power 7 is when we multiply this, the expansion here, multiplied by this, to give us the x to the power 7 would be when we multiply by x to the power 6. So I said that really badly. Right, if we want x to the power 7, and we already have an x out here, the only way of expanding it to get x to the power 7 is when we multiply our x to the power 6 term by this. Hopefully I said that better that time, I don't know. So that means that we're now going to do 5x multiplied by 6, 7, 2, 6 gives us a power of 7, because there's a secret 1. So apparently 5 multiplied by 6, 7, 2 is 3360. I hope that makes sense. Oh, darn it. This one's all on the calculator. Ah. Alright, so this is where we have to go into the stats functions. So you need to enter the information into your list 1. Okay, so if you enter all of these pieces of information to L1, all of these pieces of information to L2, and then you go to stat, I forget them now. Stat 1 var stats, and then I think it's len reg. You should see it, ax plus b. I'm going to have to show you that there. Now, when you do that, when you find your equation, it should say a equals b equals, and so you can establish those. But it should also say underneath it r equals. Now, if it doesn't, we did have this discussion quite a lot, it means your diagnostics are not on your calculator, so you need to turn your diagnostics on. Again, I will make sure that I go through all of your calculators and make sure that they're on, because your diagnostics need to be on, and it literally just pops up as a number. So apparently, once you've rounded it properly, the value of a is 1.92, b is 7.98, and r should pop up to be 0.985. Remember, you're rounding everything to 3 sig fic. It then says use your equation to estimate the mean weight of a child that's 1.95 years old. So obviously that means you're substituting this as your value of x. So you're saying 1.92 multiplied by 1.95 plus 7.98. and you calculate that, and that apparently gives us 11.7. Okay. Okay, so this one we really need the calc as well. Alright, I'm going to pause for now and see if I can get the calculator working on this computer.